Hello, welcome back, guys. This is Surendra, and I am going to continue my digital lecture series. So, first of all, I want to say that because of some reason, I didn't have uploaded the lecture since last 2 months. So, now I will upload daily at least one lecture. It can be two also. So, I will recap what we have done previous. So we started with number system. Then after we have done Boolean algebra, then combinational circuit, and then we are going to start sequential circuit. We already have started and covered one topic called SR latch. So in SR latch, uh, I have implemented using both NAND gate and NOR gate. So now today I am going to cover SR flip flop. But before switch to flip flop, first I will introduce what is clock and what is the mode of operation, like positive is triggered, negative is triggered, positive level and negative level. So first I will introduce that term, and then after that we will see the flip flop. Make sure that you have watched the SR lecture, because that is useful for this lecture. So please watch. If you already know, then you don't need to watch the lecture. So first we will see the what is clock. So clock is the signal, looks like this. Looks like this. What for some time it is like 0, and for some time it has some voltage. So it is clock. So here the duty cycle of clock is 50%. 50%. That means it is on for 50%, then on for 50%, then off for 50%, on for 50% and off for 50%. There are four mode of operation. So we will look at what they are. So first, like, if here this is 0 and we will consider this is 1. So if like flip flop is working in this region, in this region, so that is called positive positive is triggered, is triggered, and denoted by like arrow only, arrow. Like suppose this is flip flop symbol, so we will do like this. Here this is clock, so this is positive is triggered if the flip flop is working in this region, like when this is switch 0 to 1. And if like the flip flop is working, it is like 1 to 0, 1 to 0, it is coming from 1 to 0. So this is 0 to 1 means positive, 1 to 0 means negative. So this will be negative is triggered. So it is denoted by the bubble. Here this will be bubble like this. So this is the symbol of negative is triggered. And third one is positive positive level triggered, level triggered. Positive level triggered means if the flip flop is working in at higher voltage, like it is working in this range, so that will be positive level triggered, and it is denoted by a symbol this. And third one is negative. Negative means just opposite. This will be at 0, so it will work at 0. So this is negative. Negative is triggered, and it is denoted by here bubble this. So this is the representation of all the four modes. And this is the clock pulse. We give one square pulse. The duty cycle of that is 50%. And if the flip flop is working from 0 to 1, like in this region, so that will be positive. And if it coming 1 to 0, that will be negative. Like every this is the control signal. So when it, like I have said that this flip flop is working positive, this is positive is triggered flip flop. So when this pulse will come, here also come, here also will come, here also will come. When this pulse will come, it will give output. And if I said negative is, so that will work in negative is. So when the pulse is changing from 0 to 1, that is negative is, so the flip flop give output at this pulse. If I said that the flip flop is positive label triggered, so the flip flop will work when this pulse will come. So this is positive label triggered and same negative label triggered. So this is all about the mode of flip flop. Then after we will see what is SR flip flop. So guys, I have made this table of SR latch using NAND gate. We already have discussed this thing. So when the input is 0 0, then it is invalid. When input is 0 1, it will give 1 and 0. When input is 1 0, it will give 0 1, and when input is 1 1, it will give Q1 and Q. Means this will be memory only. So what now? This is the circuit for SR flip flop. So first we will see what is the part of SR latch. Why I am saying that SR latch truth table is important, because this is nothing but SR latch. SR latch. This is SR latch, and this whole circuitry is SR flip flop. Here I have introduced one control signal, that is called clock. I already have introduced what is this clock signal is. So we will see what will be the output here. Here will be the output like S into clock ka whole bar. This is NAND gate. So this will be S bar plus clock bar, and for here the output will be R into clock ka whole bar. That will be R bar plus clock ka bar. So now we will this is also the block diagram representation for SR latch, SR flip flop, sorry. Now we will see so this is the table, and this is the flip flop. Now we will try to implement the truth table for SR flip flop. SR Q and bar. So if S and R are 0 and 0, 0 and 0, starting from this is also clock signal, introduce clock also, clock. So if clock is 0, suppose clock is 0, so this clock is 0, so here what the S bar plus clock bar, here this is 0, so this will be 1 plus something will be 1 only. So this will be 1, and this also will be 1, same thing, R bar plus clock bar. So this will be 1 plus something will be 1. So 1 1, for 1 1 the output is memory. This will be memory only. Whatever we have previously, this will not be depend on S and R value. So whatever we have previously, that will be only the output. And when the clock is 0, oh sorry 1, when clock is 1, so clock 1 bar is 0, 1 bar is here, also 1 bar is 0, because here I will write R bar plus clock bar. So this also will be 0, so 0 0, so 0 plus something will be something. So now it will depend on S and R value. Suppose the value of S and R is equal to 0 and 0 0. So 0 0. So here the input will be 1 and 1. So for 1 the output will be here. We have seen in SR latch. So output is QN. Means QN. That is memory. So if the clock is 1 and I have given input as 0 0. So 0 0, the output is memory only. Memory. Whatever they have. And then after that, if the input is like s is 0 and r is 1. So if the input s is 0 and r is 1, so here the clock is 1, so this here will be s bar, so s bar will be 1 and this will be 0, so if s is 1 and this is 0, so what will be the output? 0 and 1, 0 and 1. For what? Here we have given when 0 and 1, when s is 0 and r is 1. So the 0 bar will be 1 and 1 bar will be 0. So for 1 and 0 input, this will be 0 and 1. So when clock is 1 and this is 0, this is 1, so output will be 0 1 only. Then next when s is 1 and r is 0, so here the output here will be 1 bar will be 0, here will be 1, here will be 1 1. So for 0 1, what will be the for 0 for 0 1, what will be the output? 1 and 0, 0 1 1 and 0. So for 1 and 0, this will be 1 and 0. If the output, if the input is 0, if the input is 1 and 1, 1 and 1, so that will be 0 and 0. So what we have seen, for 0 and 0, the condition is invalid. So here the for SR flip-flop, the condition is invalid for 1 and 1 because that is complemented. We are using the NAND gate, so that complement. So that's why this will be the table for SR flip-flop. Then what we will see, what is characteristic table and what is excitation table. So dear friends, if you are not getting this thing, then please let me know what is the problem. Is the problem in my teaching skill, or is the problem in how I should teach or something? So you can comment what is the problem, so that I will try to resolve that problem. And next we will see what is characteristic table. So here we will take three inputs, S, R and Qn, and we will see what is Qn plus 1. So first we are considering the clock is 1 only. So first, when the input is 0 0 0 0 0 0, so what is if Qn is 0? So we have seen here that if input is 0 0, the means output will be memory only. So whatever Qn is, that will be Qn plus 1. So that will be Qn plus 1. If input is 0 0 and Qn is 1, that will be memory only. If input is 0 1 0 1 0 1, here we will take two conditions, when Q1 is 0 and Qn is 1. So here we have seen that if input is 0 and 1, what will be the output? Always output will be, this is our output, and So output will be 0 only. This is the complement, so you don't need to worry about this is the output, man. Qn n plus 1. So here, if the memory is something, so that same will be here also. This is the output, this is the output, this is the complement of this thing. So here what will be the output? Always output will be 0 0. That will not be depend on the previous value. If the input is 1 and 0, 1 and 0, and the qn is 0, 1 and 0, and qn is 1, so 0. So always, if input is 1 and 0, it is not depend on qn, it is directly given output as 1. So it will be 1 1, whether the qn is 0 or 1, it will not depend on this one. And then what if input is 1 and 1, 1 and 1? So if input is 1 1 and 1, 1 and 1, so we have seen that that is an invalid, so don't care, because this condition cannot handle the SR flip-flop. The straightforward answer, that if the input is 1 and 1, then the SR flip-flop cannot handle this condition, because we have already seen that the qn is equal to qn bar cannot happen any time. So this condition lead to this situation. So that means that SR flip flop cannot handle this condition. So if you want to see this, is if S and R input is 0 0, then this will be qn only, this will be always 0, this will be always 1, and this will be always don't care. So in a characteristic table, what we have to do, we have to do that we have to implement how the circuit can be implemented, like SR flip-flop can be implemented using something like if you have this thing, we have to place in K-map, and after that we have to see that what is the equation for characteristic equation. So place, like we already have seen the K map, so you don't need to worry about too much thing. If as R and Qn, this is 0 0 0 1 1 1 and 1 0, this is 0 1, this is 0 0 0 0 0 0 0, this is 0 only, we will place 1 only. So this is 0 0, this is this thing, we have done this thing. So now we have to place the value of qn plus 1 in this table. So that is for 1, for 2 that is 0 only, for 3 that is 0 only, for 4 that is 1, for 4 that is 1, for 4 that is 1, for 5 that is 1, for 6 that is don't care, for 7 that is don't care. So now you have to solve the K map. So it is so much easy, I cannot explain too much. So we will make one these two. Yeah. Now what will be the output for this? All thing is changing, so S only for this, these two are changing, so this will be R bar into Qn. So Qn plus 1 is equal to S plus R bar Qn. So this is the equation. By this equation, we can predict that what will be the output if the S and R is this thing and Qn is this thing. Then we can predict by this thing. This is not valid for what? When S into R is equal to 1, because when S and R is equal to 1, uh, then this is not valid. This is invalid for this condition, invalid for this condition. Now we will see what is excitation table. So excitation table also, I need this table. So please remember, I cannot show both the pages, so please cooperate with me. So guys, thank you for Then after that, what we are seeing that excitation table. So in excitation table, what we will see, the qn and qn plus 1 is the input, and the s and r will be the output. What will be the output we have to see. So how to make this table, I will show you. And second thing is that, don't think that this is the waste of time. This is useful for implementation of some other circuitry using some flip flop, or some other flip flop using this flip flop. So we will write for 0 0 0 1 1 0 1 1. So these four conditions are for two input. So now we will see, when the previous input is 0 and final output is 0 only. So what are the conditions for this one? When will be the output 0? When s is 0 and r is 1. So this condition lead to the output is the output is 0. And when the qn is equal to qn plus 1, when this condition happen, when both are 0. So for this thing, what will be the s will be 0 and r can be anything. So for this condition, the s will be 0 and r can be anything. And 0 1, when this condition will happen, 0 1 will be happen only on in 1 and 0, when s is 1 and r is 0. Then qn will be 1 only. And there is no condition for toggle. So this is the only condition for this thing. So that will be 1 and 0. And similarly for this one, that will be 0 and 1. For 1 1, for 1 1, that is qn is equal to qn plus 1. That condition is for s is equal to 0 and r is equal to 0. And when this qn plus 1 is 1, when the s input is 1 and r input is 0. So for we can write for this one, the s is don't care and r is 0. So this is don't care and r is 0 0. So this is excitation table. So thank you that's it for today's lecture. And we will see in next lecture the jk flip flop that will remove the disadvantage of sr flip flop, that is the invalid condition. In that means that can handle this condition also, when input is when s and r is 1, that can handle. So we will see in next lecture. And please keep in mind these all excitation and characteristic table that will be useful for implementation of some circuitry using flip flop. So thank you very much.